hope you had a good lunch. Great. In the near future, the job profile for operations and for DevOps engineers will change dramatically again. DevOps practices, cloud platforms, and container platforms allow for automation like you've never seen before. Let me show you what the future brings.
Hey, Michelle, where are you?
On my way to the client. Stuck in traffic. What's up?
Customers cannot log in. I've already alerted the team. Should I give John a heads up?
Go ahead.
Good morning, Angie.
What do we know about the problem, Davis?
The last deployment triggered a login issue. Website login is timing out because of a surge in database service failures. I've initiated a rollback and can confirm that login is now working again. Hello? Anybody want to hear a joke? Hello?
Nice, right? It's a good look into the future. Wouldn't you all like to do something like that? So let's take a look what the future has in for you by looking at where we are now. So a lot of companies out there doing DevOps right now. Gone are the times where development teams use their packages, throw it over the wall to the operation teams and be like, it's your problem now, not mine anymore. Werner Vogel's punctually brought it to the point and said, you build it and you run it. That's all that DevOps is about. Development, so programmers and operations people have the same or at least an aligned tool set and work towards a common goal. And that is more quality and faster time to market. So increasing the speed of deployments to push features as fast as possible from development through to production. So to do DevOps the proper way, you need visibility. You need visibility into your applications. You need visibility into your entire application environment. And right now, the companies that we talk to have about 5% visibility in their systems. And why is that? Why it's only 5%? Well, because it's hard. It's not easy. There is not enough time, there are not enough people to actually look at all of the parts of your application that you have. And so what you do is you focus on the most important pieces, right? But experience tells us that also the not so important pieces break on a regular basis. And then you have to spend a lot of time to actually find out what the root cause to a certain problem was. So in order to go where we saw, what we just saw in the video, you should aim somewhere towards 100% visibility. And why is it so hard to actually achieve 100%? Take a look at the application environments you're dealing with today. You have container and cloud platforms that allow for fast deployments. That's good, that's awesome. That's actually where we need to be. We need to have a fast time to market, but also with quality gates in place. And while it actually allows for individual microservice teams to have independent release cycles and deploy on a regular basis, it also increases the operational complexity. So you have to actually also move from monolithic applications to microservice applications. So you need to embrace those OpenShifts, Cloud Foundries, Kubernetes out there to actually achieve what we saw in the video. What was once a memory call in a monolithic application is now a network call. So complexity increases with those container platforms. Add Istio in there, service meshes. You immediately have 3 new technologies, 3 more hops where actually something could go wrong. And if you get the egress rule wrong for Envoy, well, you won't be able to talk to anyone. So applications are incredibly complex right now, and even the subject matter experts for any given application, if you ask them a question about their application, so what happens if I press this specific button, end to end? From front end, through the business logic, through your container platform, down to the database. There are very few people that can actually tell you what happens end to end because they simply don't know. So let me tell you how a journey to autonomous cloud operations can look like. So you can actually do what the people in the video have done. Be carefree, and you have a monitoring solution in place that actually informs you when something is wrong and needs your attention, but takes care of it as much as possible. We have identified that there are 5 stages. And though this might not be true for all of you or for all of the companies out there, it definitely runs somewhere along those lines. So bear with me. The 5 stages are, you need to actually have people that have time to actually do what you're trying to do, right? So you really need to embrace automation. We're going to jump into each of the phases in a few seconds a little more. Then you need to do the cloud migration. Get rid of your monolithic applications, throw it away. Move it to microservice, to containers, and let it scale automatically. Implement safety nets, so you don't push bad commits through to production. Then you could actually introduce auto-remediation. So if something happens, you can add a remediation script that is automatically executed and maybe just as a rollback to the previous version. And in the end, you can automate everything. So this is the ultimate stage and the ultimate goal. So let's take a closer look at the first stage. The goal in this stage is actually to increase visibility into your applications and your application environment, and to free up resources that actually can do what you are trying to do. So who of you are familiar with the term war room? Wow, okay, a lot, great. So usually it goes like this. The development teams pick their tool of choice for monitoring. And that is great, because it's up to them, basically. But each team chooses their own tool. And when a problem comes, and you are in a situation like that, in a round circle, and everybody is like, well, my monitoring tool tells me that the problem is not in my service. It's got to be your problem. And then you tell me, well, my monitoring tool also tells me it's okay. So it can't be my problem. And it goes on and on and on, and finger pointing, shouting, until someone comes in and actually asks the questions, if all of your tools would have worked, we actually wouldn't be here. So you better figure out what the problem is and fix it. So the goal is, on the one hand, to maybe find a common denominator for those tools, so you have a single platform, that all of your teams have a single pane of glass and everybody looks at the same data. You need to find a solution where you can actually pull that to. There are several out there that can do that. Choose yours. And what you then actually get is real visibility into your systems, into your services, into your applications. So you're squinting your eyes, it's really bright, right? And it's also hard to read. But what you see here then, all of a sudden, if you get visibility into your systems, you see which services call other services, where most of the time is spent, and which service actually calls back to other services and databases. And you would need those visibility not only on the service level, but also on application level, so real user monitoring, measuring the user experience of your customers. Is your checkout process working fast enough? Or are all of your customers currently switching to Amazon and buy there again because it's just too slow? Insights into services, insights into processes. Do I have too much network retransmissions on my process level? insight into host metrics. Am I running out of memory? Is the disk running full? It could be the root cause for a lot of problems, actually. And in the end, if you run on any cloud platform, you also need insights into that. Because just because you run on AWS does not magically make everything run smooth. Phase 2, enable autonomous operations. Get rid of monolithic applications, move to microservices. Not my favorite side, it's just. So the goal is actually having microservices in place and have a continuous delivery pipeline. Who does not know what a continuous delivery pipeline is? I asked a question wrong. Nobody will show his hand now. We will cover it in a second. So what comes with microservices? Polyglot technology platforms. Every microservice team can choose their technology they want to use. Is it Java? Is it .NET Core? Is it PHP? Is it Python? What have you? They can choose that, and that's a good thing. But it introduces a whole new level of complexity, because all of a sudden you need to support several programming languages. And you need to get insights into all of those. So this is not even an up-to-date screenshot. So the possibilities are endless, growing by the day. You see all of these startups pushing out there. And what have you in here? You have infrastructure as a service layer. You have platform as a service layer with OpenShift, Cloud Foundry, Kubernetes and style. Configuration automation tools that actually allow you to provision your workloads on your infrastructure as a service components, for example. And then all of these application frameworks. So microservices are a good thing, because actually one single team has end-to-end responsibility for a specific part of your domain. But from an operational perspective, it can increase complexity. CI/CD pipeline. So how that works is you have a code versioning system, and I assume everyone has one. The developer checks in the code. It's built automatically in Jenkins or TeamCity or what have you. It automatically pushes the last code changes to the development stage, where you can test it, you can run performance tests, integration tests, smoke tests, just see if it works. And also if it works as expected. Also take care of performance. Maybe the performance breaks because of a change. You need to be aware of that. Then you have an approval step, and you can move to staging environment. Another approval step, and you can actually ship it to production. So who of you sees a problem in this picture from an automation perspective? Yes? Too many humans involved. Your words. Perfect. Perfect analysis. If you really want to actually shorten your release cycles from weeks and months to minutes and hours, you don't necessarily need to get rid of those humans, but you need to get rid of the human interactions that are necessary to push it to production. That's why we implement safety nets in the next phase. So the goal is, on the one hand, to shift left quality and shift right information, and to actually create an unbreakable continuous delivery pipeline. So by shifting left, what I mean, we had the example of the performance issue before. So take the example, and your latest code change is pushed to your staging environment, and you already know the performance benchmark from the previous build. You push a code change, you run the same performance test, and you see that the response time increases. And based on that information, you can actually make decisions to just not push this through to production, just break it early, let it not break in production, because then your customers will be affected. This way, they're not. The pipeline just stops. And by shifting right, what I mean with that, push as much metadata as you can, as far as down the pipeline as you possibly can. So take a look at the service here. We immediately know that this service is deployed in our staging phase right now. We get details of the deployment events. We know who did the change. We have the ID of the change. We know who authorized the Git commit. We have all the details in place that we can actually follow up directly with the developer that is actually responsible for this, if anything breaks. And now let me introduce to you the unbreakable pipeline. It's a concept that a colleague of mine actually introduced. There is a workshop online on GitHub, if you actually want to follow through with that. And he built the example based on AWS code pipeline. And it goes like this. The user commits his code to his code versioning system, and automatically a build is triggered that pushes it to the staging environment. What happens now? Shifting right. You push all of the information about that specific deployment down your pipeline to your one integrated solution where you keep all your data. So we have the picture as we saw in the slide before. Next, what happens? Approved staging. We're getting rid of the humans, correct? Because this is also something that a machine can do. In this example, a Lambda function is called that actually validates the build. And it does that by actually comparing the response time, the average response time over a specific amount of time with the one from the previous build. And if it reaches a tipping point where it's just like where it deviates too much from the previous response time, it automatically rejects this build and the pipeline stops. But if it approves, it's okay, you can continue. Push it to the next stage. That is actually production, where you again push the deployment information into your monitoring solution. So you have everything in one place. And you can again do the same step in the production stage. Then you can go for failure rates, for HTTP 500 errors. You can go for anything you can imagine. And if you actually find a problem, you can configure another Lambda function that actually triggers a rollback of that. So now you're in production, something breaks because of a not so perfect code commit, and you can automatically detect it and automatically roll it back to the last version that has worked. That is what we understand as an unbreakable code pipeline, because you just can't push bad code to production. And that allows you actually to go to the next phase, auto-remediation. This is again a service, and we see that there is a problem. And we also have the deployment information there. Now in this case, there is a little detail that was added. So you have all of the deployment information we saw before, but in addition, we also have a remediation action defined. So you can define the thresholds, and you can define the remediation action that is executed if one of those thresholds is hit. So what you've built, you just built the self-healing application. If something breaks, this remediation action is executed and rolls back to the previous version that has worked. For that example, we used Ansible Tower as like our go-to guy that actually executes then the remediation script. Works pretty well. And this is actually the path to autonomous cloud operations. Because if you know what the problem is and there are a certain set of common problem patterns, you don't need to escalate at 2 a.m. You don't need to wake up the operation guys immediately. But if you have enough details about the problem evolution and what actually goes wrong, you can try to auto-mitigate it using configuration management tools like Ansible Tower, for example, that can execute remediation scripts that have been configured for that. So are you running out of CPU? Scale up your application, put a load balancer in front, you should be good to go. Too high garbage collection? Well, adjust the memory settings. If you can define the response to a specific problem, you most likely will be able to put it in code, so it can be done automatically. Do you do blue-green deployments and blue doesn't work as well? Go back to green, go back to blue, whatever direction you're working. Is any application hung? Restart it. Is the impact mitigated at that level? Update the dev tickets. Let them know what you did. Let them know that you executed 3 remediation scripts and the problem was fixed. If that's not the case, initiate the rollback and go back to the previous version that has been working good. If then also the problem is not resolved, then you can actually escalate and wake the developer up. Maybe by that time it's 7 a.m., so it's not that early anymore. And then you can actually get to the state where you can automate everything. If you've done all of the previous stages, you can go for it. Not many companies are at that level, to be true. But what you could actually do is you can identify common error patterns. And then a virtual assistant can ask you if it should execute the remediation action. By the way, the scale-up costs $400. So please, Mr. Business Executive, approve my remediation action. This could be the only interaction that is necessary going forward. And by virtual assistants, I don't mean like Microsoft Word paperclips that always thinks you're writing a letter, but really useful virtual assistants like we saw in the video before. And after all that, you can use it for specific work use cases. Microservices team stand-up. You can actually use voice ops to interact with your integrated data solution. How has my microservice been doing for the last 2 weeks? You don't have to be a performance geek to ask the question, right? If you can formulate the question, you get answers. If you need details, then you can drill down immediately. Also works for a board meeting. If you have user experience data in your solution as well, you can actually ask, is my revenue really increasing since the last update? And how is the user experience in Hamburg right now? These are questions that can be answered immediately. And the real deal is then if you actually configure your applications to react to those events. So even take it a step further. So bear with me for these 2 examples. This is a shop where you can buy coffee makers and coffee. If the performance goes down for this specific site, the users and customers might go to a different site that's faster. So what can you do to actually mitigate the time that you need to fix the problem that is the underlying problem here? You can open up a chat window and you can tell them, wow, we're really sorry, we know the page is slow right now. But since we actually have our platform connected to also our CRM tools, we know you bought a coffee maker 2 weeks ago. So here, have a free descaling set for that, and we give you free shipping costs for your next order. If you actually implement those in your applications, your customers will run around and tell everyone about this experience and not that the shop was slow. And this is the kind of PR you're actually going for if you have a shop. Next example of what you could do, fashion shop. If the performance goes down for a certain geo region, for example, so only APAC is affected, or only iPhone users are affected, or only people that are adventurous enough to use Microsoft Edge are affected. You can show a dark page or a pop-up for those specific user group. And you can again mitigate by, here you get a free 10% discount code for your next purchase. And this message are only seen by the affected users. For the other users, the application works fine. So you really can actually act on business metrics to continue to grow your business. And by that, you could actually, instead of losing 100% because your customer leaves and just buys at Amazon, you're making 90% because you give him a 10% discount. So what? And happy customers tell other customers about their experience. But you're not making 90%. There's a mathematical error in there. Because you only give the discount to those people that are affected, right? So if 20% of your users are affected, you actually make 89% of your revenue and have happy customers. So this is the journey to autonomous cloud operations as we envision it. So and what does this mean for you? So I usually end my meetings at the company I work for with action items. And I have a few action items for you, what you could do tomorrow. Because when I get home from all these conferences, usually, yeah, I heard this awesome talk and I wanted to follow up with that, but then day-to-day work happens and I forget about it. Didn't know what to follow up with. You could do what we did. We shut down our NOC end of last year. It's just not there anymore. Also, we don't need it anymore because you just saw what we have. If you also want to go down that route, we are currently working on workshops where we can actually work together with companies around cloud migration, around auto-remediation, and around autonomous operations. So if you're interested in that, find me afterwards, or go to the booth in there. We have a booth. Drink a beer with me at the evening event, and let's talk. So I don't want to encourage you to close your NOC right away. You can do it, but this is what the NOC looks like right now. So we bought a ping pong table and put it in there and a billiard table. I also don't want you to immediately buy a ping pong table after this talk. So this is not the action item I want to leave you with. This is what you should do tomorrow. Take a look at your enterprise, at your company. Define KPIs. How are you doing at different levels? What's the number of failed business transactions you have? What's your development to ops ratio? 100 to 1, 10 to 3? And the easiest KPI to start with actually is how fast are you able to push code changes from development through to production? Is it days? Is it weeks? Is it months? Do you want to be competitive in your environment, in your business direction? Then it's probably a good idea to start there. Make sure you shorten your release cycles. Create a realistic goal. Go from 3 months to 2 weeks. And once you're there, you can actually refine and go even faster. So you've heard the story. You have seen the goal. And I've even given you a starting point. So for those of you who are already on their journey, great, good for you, you're going in the right direction. For everybody else in the room, your autonomous cloud operation story can start right now. Thanks. Are there any questions in the room? So if you're interested in this talk to I don't know, show it your children at home, there is the SlideShare link up. You can just copy it. I will also post it on Twitter afterward and using my Twitter handle. And yeah, if you have any questions about what we've discussed, come to the booth or find me. I'm here until tomorrow afternoon. Let's have a discussion what your cloud journey looks like right now. Thank you.